Okay, so we'll just start with the basics of condensation polymerization. So the easiest polymers that you can do with the condensation reactions are polyester and polyamide. And it's more of the condensation reaction, but just happens twice between two molecules that have the functional groups on both ends. And I normally think of it as like if you have two person, like a boy and a girl, and then just alternate and they hold hands. So the arms they reach out, the hands they reach out are the same functional groups, and then and the boy and the girl have different functional groups, and then they condensate and then join together, and then you have a super long chain of the repeating units. So the polyester, you can do this with the dicarboxylic acid, which is in your notes. So dicarboxylic acid with a diol, and you need heat, and you need H+, just same as your condensation reaction. Or you can make it with a diacyl chloride and another diol, but this one you don't need any reagent because the diol is more reactive. So with the polyester, you can think of it like COOH, COOH. So whatever is in between doesn't really matter. It's just a copy paste. And then if I react this with a diol, like say if I say like OH C then some more OH on the other side. So what actually happens here is you can think of it as the OH, which is a function group of the carbon, and then the hydrogen, which is the COOH, the H which is technically the functional group of the COOH, because as a carboxylic acid always loses the H+. So these two suckers bugger off and they make water, which is a condensate. So this is gone, and then the rest just joins together. Okay, so it happens on the other side as well. So it happens on this side as well. So I'm just like say on this side, I'm gonna draw exactly the same thing. So just alternate. So what's gonna happen here as well is that you're gonna lose the OH and the H. So this is gonna go, this is gonna go, and then you just join them together. So at the beginning of doing this section, it's like say if you struggle at the beginning, it's always easier just to do two repeating units. So it's like drawing X and then draw Y, then draw X and then draw Y, and then do the condensation. So your end molecule will always look something like this, like CO, and then whatever, then CO, whatever. Oops, that can't be whatever, that has to be an O, and then this is your alcohol, like your carbons, whatever that is, and then your O, and then C. You can think of it just repeat into something like this, into the carbons, into the O, and just repeat. And what you can see is that the bits in the middle that's being repeated, you can think of it like if you cut it here, you always look for the COO bond, you cut between the carbon oxygen single bond, and then you can see this is the original alcohol, which is being repeated, which is over here, and then the carboxylic acid, the dicarboxylic acid is the same. It's just being repeated, and then you lose water as a condensate. And with the diacyl chloride, it's exactly the same thing. You just have COCl with the COCl, and then you have the same thing, the OHs on the side with the carbon with the OHs. And what's going to happen here is the same thing, that the Cl and the H are going to bugger off to make HCl as your condensate, and then you just join them together. So it becomes the same. It becomes the same thing pretty much. And the polyamide is exactly the same thing, except instead of a dicarboxylic acid, you have you still use a dicarboxylic acid, sorry, instead of using a diol, so you have a dicarboxylic acid, and in this time you have plus an amine, and you have to heat this. And then the other one you use same thing, acyl chloride, and then you also use amine, but this one you don't need to heat because it's more reactive. So in this case, you're just going to make CO bonding to whatever the thing in the middle. I'm just going to put R here with a C double bond O, and then this time you have the nitrogen because it's the amine, it's not OH anymore. You lose you lose the H from the amine and the OH from the COOH, and then it just looks like this. Okay, so it just kind of looks like that. So it's exactly the same thing, but instead of oxygen in the middle, you have a nitrogen in the middle. Okay, so it's you know, it's, I'm trying to, I'll probably do more examples for the proteins, but because most of you guys in this core already know how to do this. But do the hydrolysis. I'll do a hydrolysis properly. All right, I'll do one properly. All right, let's say you do amide. Let's say if I do COOH with CH2 5 COOH, and then OH CH2 2, and then OH. Okay, so this is a actually, let's change this. Let's change this to NH2, NH2, NH2. Let's make an amide. So I'm gonna heat this bad boy. So what's gonna happen? So you can think of it at the beginning, right? Like say here's a working process. If you struggle at the beginning, I'll just draw two of these. It's a lot of copy and pasting. Just put them right next to each other, facing each other, face the function groups towards each other. And it's the same process for all the condensation polymer for the polymers. So it doesn't matter what you get given. Jesus, I'm running out of space. I have this problem on the whiteboard, and I have this problem as well. So same thing. What's going to happen here is that this OH and this H, they're going to go make water. This H, this OH gonna go make water. This OH, this H, they're gonna go make water. So what's gonna happen is that this is gone, this is gone, this is this. One of the H's is gone. Actually, I shouldn't cross out the H. I should cross out the 2. Okay, oops. So I'm gonna cross out the 2. Cross out the 2. Cross out the OH, cross out the 2, so and then you just join them together. So you join, and then where is it? Join them together, and what you're gonna get is if I just copy paste that, you can see this is what I'm gonna draw. CH2 5. I'm just showing all the working out. So this OH is gone. This is gonna go to the N, and this still has one of the H's left. You're only deleting one of the H's. And then at the end of the day, it's just a lot of copy and pasting. That's why I keep saying to the other things, it's really not hard. And if you can't copy paste, I don't know what, you know. Right, I just copy pasted everything, okay? Now, the same thing applies, like say if you want to draw the repeating units, like you know, the bracket N section, what you could do is, again, if you just find the CON, and then you cut the CN single bond, cut the CN single bond, like here, cut the CN single bond, cut the CN single bond, then you should be able to see this thing in the middle that I'm highlighting right now. These are the 2 repeating units. And then so therefore, for this particular question, the polymer will look like this. C.1O, N. So this, it just means this thing in the middle, I've just copy pasted it in, and that's being repeated n times. Okay. Now if I were to do the hydrolysis, now just remember the acid-base hydrolysis. So if I do acid hydrolysis, so that means you add water, add heat, add a bit of acid, and what's going to happen here is that you will break the CON single bond. You're gonna you know, it just always cut the line, draw the line there, and then you're just going to copy paste. So for the acid hydrolysis, actually, let's just continue this line here. We're going to separate that. So if I use acid hydrolysis, before we even do anything, you can just copy paste the products. Copy paste the products, like say right here, so NH, again, just copy paste, just copy paste, COCH25, C double bond R. Okay, so these are the two products, and as you can see that they're rather incomplete. So what we could do is that we can complete them. So this is supposed to be NH2, this is supposed to be, get rid of this is supposed to be NH2, and this is supposed to be COOH, and this is supposed to be COOH. So you're returning the water into them. But here you need to look at the condition. This is acid hydrolysis, and then this amine that you have produced, that will straight away be neutralized because of the presence of the acidic condition. So this thing that I've drawn is no longer gonna be there. This will be receiving another proton from the acid, and then this carboxylic acid and this ammonium creature is your products. Okay, now for your base hydrolysis, so for your base hydrolysis, it's the same thing. Again, you just copy paste, you know, the thing that we have above us, just copy them in. Actually, I'm gonna delete this, I'm gonna delete that. Just copy them in. And then same thing, you can complete them. This is NH2, this is COOH, this is COOH. And then once you've done that, you need to come back and look at the hydrolysis. This is alkaline, base hydrolysis. So that means my carboxylic acid are going to be neutralized. So I'm not going to have this anymore. This is going to further be neutralized into COO minus, and then CH25, and you just, the stuff in the middle, you just copy paste. Okay, so this and this are my final products. And if you can do that and do a bit of justification, and that's excellence. Okay, so that's the stuff that the girls in the core missed that. With the protein stuff, this is where all of you missed that. Now protein is really unique, and this is where a lot of the excellence question comes in. Okay, because with the, I mean, if you look at it, if you look at the four products that are withdrawn, so with the polymer like polyamide, if I do acidic condition, I change one of the products. After, you know, after they're produced, I need to do the neutralization. The other, for base hydrolysis, I also change one of the products. So there are four products, and you only need to further react two of them because of the neutralization. However, if you do protein, you got to change all of them, and that's why this is typically what they give you. Now, what is a protein? Protein is monomers. Protein is polymers made of amino acids. And what are amino acids? So if you think about the name amino acid, amino means you have a NH2 or NH somewhere. Acid is you have a COOH. So that means you will have a typical amino acid with a functional group that looks something like, you know, the stuff in the middle doesn't matter. That looks something like this. You don't have to necessarily have two hydrogens. You can have a carbon, methyl groups, you know, other stuff attached to it, to the nitrogen, but it has to have you know, the amino group on one end. So this is why this is called the amino acids. This is amino, this is acid. Now one thing that proteins actually do, because by nature the COOH is a carboxylic acid which want to donate a proton, and then the NH2, which is alkaline by nature, will accept the proton. So what's going to happen is that this is going to the COOH, the proton, the oxygen, the hydrogen here will actually make its way towards the nitrogen on the other side, and this is what you would have seen in your note. This is what we call a Zwitterion, so which is a very stable and very high melting point, all that sort of stuff, because they're already donated and accepted protons, so they kind of lost their acidic or alkaline properties, so they're very stable that way. But the thing is, with the protein, as you can see, we no longer have the same functional groups anymore on both sides. They're actually different. So if I give you something like that, CH3COH, like I'll just do something really simple. I say NH2. If I do another one, I'll just make it a little bit bigger, NH2. So these are the two amino acids. I just made it up. So if I want to do a polymer out of these two monomers, there are actually two ways that you can do it. The first way, the answer number one is, like, say, if I do a condensation reaction between these two right now, the way they're orientated, if I keep this thing on the left, keep this thing on the right, and hopefully you can see straight away is that the H from here and the OH from here are going to condensate, and then that means this is gone, and then you just join the rest together, and you will just copy paste everything else as you see them, and then you can do the ends, if you want to repeat them. Now for the other option is that I keep this on the right, keep this on the left. So if I do that, that means I put this guy on the left hand side, CH23, and they sometimes ask you this. They give you two options. So this time, now if you really want to, what you could do is to copy this here and then move it to this side. So you can do what we did for the first example, and then you just copy it. So CO, CH2, NH2. Okay, so there are actually two ways of drawing it, and this is kind of like a merit-ish type of question, because they give you the two amino acids and they ask for you to draw them in two different ways, because one's on the left, one's on the right, because of the way that they no longer have the same functional groups on the both ends. So you can actually have two ways of drawing them, but that's not the most important part. But if I were to, like, say, draw a polymer using this, like, it doesn't matter, let's just go with the top orientation. So what we could do, you can do exactly the same thing as what I did just now with when I started with the polyamide example. I'm just gonna squeeze them in. And again, feel free to ask me questions, guys, it's okay. It's only being watched by a few hundred people, don't feel too embarrassed. Okay, all right. Well, I just copy pasted them in, right? So what's going to happen is that this H and this OH, they're going to go. This H, this OH, they're going to go. This H, this OH, they're going to go. And as you can see, what's going to happen is I'm going to bond here, I'm going to bond here, I'm going to bond here, and then so on and so forth. And then if I do that and draw that a little bit neater, you can see this is the polypeptide. Probably heard that word when you do bio. There you go, just copy paste them together. Alright, now what's going to happen here, if you want to do the repeating units, so same thing, grab a pen, and we're just going to cut the CN single bond, cut the CN single bond, cut the CN single bond. Remember, it's a C double bond O single NH single bond, and then this stuff in the middle, these are being repeated. So if you want to draw them out properly, just look at the thing in the middle, just copy them in as you see them. Just copy them, copy paste, and this is your polymer. Okay, and sometimes they ask you to circle the polypeptide, which is just CONH, the peptide link, the thing that connects the amino acids. All right, now if I want to do hydrolysis, if I were to do hydrolysis of this particular thing, so if I do acidic conditions, so same thing, acidic, add heat, water, and for this one we're going to do base. So same thing, you just find the CO an H, right? And then you cut between the carbon and nitrogen, and then you just copy paste. You just copy it, okay? And then you just copy it exactly the same way as you see them. Don't have to include that line because that will make it messy, but this is what you could do. Alright, so I'm just going to copy them first because there's literally 0 skills involved for this section. Alright, this is, I mean, if you think about it, this is such a free exercise. If you know what you're doing, you don't need to write a lot. Alright, so to complete them, this is COH and H2. This is, you're pretty much just returning a water in the form of OH and H back to the molecule. Alright, so those are your 2 original monomers. Now, this is where we're gonna have a look at this condition, right? So this section is acidic. So these are not my final answers, because what's gonna happen here is that they will be further neutralized, because you need to look at the ends. Okay, so this part here is acidic, and then this part here is basic. And if I said, you know, going up here, this is an acidic condition, so that means these 2 sections will react. So you will make something like this. Your carboxylic acid end won't do anything, but then your amine end will be neutralized. They will just gain another H plus to become something like this. If I do the basic end, so same thing, I look at these 2 sides, and hopefully you can see it's this side that's going to do something now, and then the final answer will be something like this. Again, just copy and pasting. It's literally just change 1 or 2 letters, and you're done. Oops. Hold on. Did I just copy the same? Oh my god, I copied that wrong. And none of you said anything, of course. I was looking at the same thing, I copied it twice. There you go. Okay, so that's it. That's with the proteins and polyamides and everything. And with that flow chart, I'll just quickly do a bit of flow charts here. So if I give you, I think the example that I gave you was alkene. Let's say if I give you, what was the one that I drew? I think it was this one, butadiene, I believe it was. This is kind of, you can think of it as the starting point of the flow chart. Because the year 13 flow charts, you need to make your way to the, you know, to the thing. So I'm just gonna speed run these stuff. So you're gonna make, you need H2O/H plus to do the major minor products. You're gonna add, you're gonna add the you're going to add these things to, you know, you're going to add the H2O across the 2 carbons. Which one's major? This one's major. This one's minor. And then this is a primary alcohol. You can turn that into an aldehyde. I'm just going to speed run this, and then you're going to turn that into carboxylic acid. And then this can be turned into a ketone. You can check your notes on this. This is really, you know, it's already in your book. All right. So when we get to the carboxylic acid, this is when we get to here. All right. This is when we get to here. You can turn this into an acyl chloride by using SOCl2, and that will give you the very reactive acyl chloride. And then you can turn it back into H2O, which is just, you know, nucleophilic substitution. You can then turn this into the same ester. Let's say if I add CH3OH, but this one you need heat and H plus. The H plus is a catalyst, also gets rid of the water to, you know, make this process go a bit faster. and then for and for this guy, if I add the same alcohol, again the same thing. What's going to happen is that you make the same ester. Okay, so you're going to make CH3, CH2, CH2, COO, CH3. But then the key thing here, again, to differentiate, is that your carboxylic acid is going to require a catalyst, but then for your acid chloride, you don't need one. And then you make the ester, and then you can do the ester hydrolysis back to this. You can do a hydrolysis back to that, and then there's that. And then you can do exactly the same thing. I'm not going to draw it here, but with the naming, you can, let's say add CH3 NH2, but then again, you need heat. And for this one, you need CH3 NH2. You don't need heat. You make the same. Make the same amide, and then you can return that into hydrolysis. You can make the carboxylic acid again. Okay. You will never make the acid chloride from hydrolysis because you're adding water into it. So you're adding the OH back into the carbonyl group, so it's always a carboxylic acid. Okay, and that's pretty much it in terms of the stuff that you guys missed, and I thought I'll do this for YouTube as well. Okay, so yeah, hopefully that helped.